Day 253 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 211, design, add, and search words data structure. The difficulty level is medium, but don't worry, we're going to keep the solution as simple and easy to understand, so let's get into it. Question says, design a data structure that supports adding new words and finding if a string matches any previously added string. Implement the word dictionary class. Word dictionary initializes the object. Void add word function adds word to the data structure. It can be matched later. Excuse me, y'all. Bool search word returns true if there's any string in the data structure that matches word or false otherwise. Word may contain dots where dots can be matched with any letter. All right, y'all. So let's break that down by looking at the example so we can see what it is that they're talking about exactly. So in the example, we have the input is an array of just the function calls. These represent the function calls. This word dictionary right here is just represents us initializing the word dictionary right here. Then we call the add word function. This is the add word function right here. Then we call the search function. This is the search function right here. And this just represents the order that we're going to call these functions, right? So first we're going to call the word dictionary. Or let me just copy and paste this over here so I can explain it better for y'all. So bring this right here. So let me see. All right, so yeah, first thing we're going to do is we're going to initialize the word dictionary class, right? So that's what this is right here. So we go ahead and get rid of this. Boom. And this right here, that's why there's a blank array right here, because we're not adding or searching, we're just initializing. So we get rid of that. Now we need to, so let's say this is the array we're adding it to. Now we need to add word, we need to add the word bad. So boom, we could add word bad right here. Boom, we called that, we could get rid of this. We already did that. Boom. Now we need to add the word dad. So we could just come right here and add the word, boom, just like this. Boom. Now we need to add the word mad. So we can just come over here, add the word mad just like this. Boom. Let's add it. Let's add it. And it's over here too, right? We add the word bad, then we add the word dad, add the word mad. This is what it would look like, right? Now we need to search for the word pad. Pad is not, we haven't added the word pad, so pad is not in this array. So when we search for it, we're going to return false. That's why the output would be false, right? So that's why we could just, it'd be a false right here, because there is no word pad in this array. So the output would be false. Boom. And you can also follow along over here in the explanation, but I just want to give you a visual representation as well. Now we can search for the word bad, so right here. And when we search for the word bad, we could return true, because the word bad is right here. We already added the word bad, so when we search for the word bad, it's right here. If we didn't add a word, then we won't be able to search for it, and we return false because we haven't added it yet. So we get rid of this. Boom, we already searched for that. Now we could search for, what we're doing now is we're searching for a word that, remember, these dots can be matched with any letter, right? It says right here, word may contain dots where dots can be matched with any letter. So that's why this output is true, because it's a dot, and the dot can be B, D, or M, right? So we could just return true because dots can be matched with any letter. Boom. So we do true right here. Get rid of this. Then we could search for the word B dot dot. Once again, dots can be any letter, so we will return true again. Boom. My bad, there's the extra search up here. But y'all get the point. That's how it works. That's what we're trying to do. So I guess it would end something like this, looking something like this. But as you can see, that's what we're trying to do, y'all. We just have to add a word, and if we've added it, and when we search for it, we return true. If we then add it and we search for it, we return false, because that means it is not in the try and we never got a chance to add it. Or we never had a chance to add it. So now that we understand the question and what the question wants us to do, let's get into the fun part, the actual solution, y'all. But before we get into the solution, if y'all need any new Apple AirPods, go ahead and check that link out in the description. And then after you do that, go ahead and like, comment, and subscribe. Once again, this is the function that we're going to write to add the word, and this is the function that we're going to write to search for the word, and it's going to return a Boolean true or false if it's there or not. So the first thing we need to do is we need to create our try class, right? So we could do that by just saying class try node, and then we're going to open up the brackets, and we could say declare a variable called children, and we'll set that equal to an array of characters, or excuse me, a dictionary with the key being a character, colon, and the value being a try node, just like that. Come outside, initialize it, and that's going to store the child nodes, each corresponding to a character. Now we are going to declare another variable called isWord. We're going to set that equal to false, and this is going to indicate whether the node marks the end of a valid word or not. So now we need to get into this word dictionary class. So in order to do that, first we need to find the root of the try. So we're just going to come right here. We're going to declare var. We're going to say var head. We're going to set that equal to try node, and that's going to represent the root of the try, right? So put parentheses at the end. Then we don't really need to initialize anything. We can go straight to this add word function. So when we start this add word function, we need to declare a variable that's gonna for the head of the node, right? Or for the root node. So we could just say declare a variable, we'll call it root, and we'll set that equal to head. Boom, just like that. Now we need to iterate over each character in the word. So in order to do that, we'll just say for ch, for short for character, in word. Boom, we're going to open up the brackets. We're going to say guard let child equal root.children. Open up the square bracket, ch, else. Come outside of the square bracket. We're going to say else. Open up the brackets. And first, let me say, we're going to check, this right here is going to check to see if the character already exists as a child node. Else, we're going to say let new node equal try node. Put the parentheses right there. So if it doesn't already exist, we need to create a new try node for that character, right? So that's what we're doing now. Now we need to add it to the current node's children, and then we need to move the iterator to the new node. So in order to do that, we're just going to say root.children, square bracket ch, set that equal to new node. Then we're going to come down here and we'll say root equals new node, just like that. Then we're going to come down here. We're just going to say continue, just like that. Now, if the character does exist, we're going to move the iterator to the child node. So in order to do that, we're going to come outside of this, and we're just going to say root equals child, just like that. My bad, y'all. Now, let me see, y'all. So now we need to mark the last node as the end of a valid word. So we could just come down here and we'll say root.isWord equals true, just like that. Now it's time to get into the search function. But before we get into the search function, we're going to need to create a depth first search with the D as in dog, depth first search helper function. So we could come outside of this search function. We need to create our helper function. We could just call it func DFS, open up the parentheses, underscore index, and that's going to be colon, that's going to be integer, comma, underscore, word, colon. That is going to be an array of character. Come outside the square bracket, comma, underscore node, excuse me, and y'all guessed it, that's going to be a try node. Boom, just like that. Come outside those parentheses, and it's going to return a Boolean for us, just like that. Now we need a base case to see if we've processed all the characters in the word or not. So in order to do that, we'll just say if index equals word dot count, open of the bracket, then we're going to return node dot is word, and once again that's going to return whether the current node marks the end of a valid word or not. So now, excuse me y'all, now we need to get the current character so we could process it. So in order to do that, we'll come outside that if statement. We'll say let char equal word square brackets index. Boom, just like that. Now we need to check to see if the character is a dot or not, right? We need to handle that. So we're gonna say if, oh yeah, just to clean up, we're gonna say if char exclamation point equal sign, quotation marks with a period in the middle. So a string, just a period string. We're gonna say, so if char does not equal a period, that's what that means. We're gonna open up the bracket. We need to see if the character is not a wildcard and check if it exists as a child node or not, right? So in order to do that, we're just gonna say guard let child equal, excuse me, should be 1D, equal node dot children square bracket char, come outside the square bracket, else open up the brackets, return false if the character is not found. So we can just say return false, just like that. Now we can continue searching with the next character in the word. So we just come down here, still inside the if, and we are going to say return DFS, use a little bit of recursion, index, excuse me, index plus 1, because we need to continue searching for the next character. So index plus 1, comma, word, comma, child, just like that. Then we come right here and we're going to say else, open up the bracket. We're going to say we need to see if the character, well, we need to try all possible children, right? So we need to say for ch in node dot children dot keys, open up the brackets. We're gonna say if let child equals node dot children square bracket ch, we are going to say, we're going to open up the brackets, come outside the, open up the brackets. We're going to recursively search with the next character for each child, right? So we're going to use some recursion, and we're going to say if DFS, open up the parentheses, index plus 1, comma, word, comma, child. We're going to return true if we get any matches, right? So we're going to come down here. Oh, excuse me, open up the brackets first. Don't want to forget the brackets, and we could just say return true. Boom. Now we need to call this function in the search. So in the search function, right? Because remember, we're calling search. We're not calling DFS, right? We're calling search. So we need to call the DFS function in the search function. So we're going to say return DFS, open up the parentheses, 0, comma, array, open up the parentheses, word, comma, head. But we're not done yet, y'all, because we need the word, we still need to return false if no valid path is found. So in order to do that, we just come all the way down here, and we can say return false, just like that. Now that should be all she wrote, y'all. Let's run it, make sure it runs properly, does what it's supposed to do. Okay, we have some errors. Let's see where the errors are. Line 31 got an error. Oh, whoa. My bad, y'all. So this, excuse me. this word should be parentheses. The parentheses should go right here, just like that. Now let's run and see how it runs. Hopefully it runs correctly. And there it is, y'all. So let's submit it. Make sure it's still accepted after we submit it. Let's see. Okay, what we got? Going kind of slow, my bad. 598 milliseconds beats 60.87% of users with Swift, y'all. Don't worry about them numbers. We'll get those numbers up as we continue down our LeetCode journey. Right now, we just want to be able to solve the problem that is presented to us, and I feel like this is a good solution that everybody can understand. And because understanding and internalizing the solution is what's going to help us when we go on to problems that we've never seen before, right? We're going to be able to take what we learned from this solution and apply it to other solutions in the future. So before we leave, y'all, get one more look at the code. It's not too much code. It's a little bit. It's a nice little bit of code, y'all, but it's not too much. It's nothing y'all can't handle. Y'all Swift programmers, ain't nothing y'all can't do. So get one more look at it. And I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.